Hi, we're Smart Labs. I'm Maria.
And I'm Shriya, and we've been doing robotics together since we were in 4th grade, and today we're here to present our concept, RoboBed. We'd like to give a big thank you to our sponsors, the Michigan Council for Women in Technology, and Robofest for letting us use the robot and camera.
RoboBed consists of 4 components: an open CV camera, a mobility system, a robotic arm, and connection to the cloud.
Millions of patients and elderly suffer poor quality of life due to lack of mobility where they live and difficulty in going to a doctor. Medical staff suffer from disease exposure, including COVID-19, and waste time traveling to patients.
In February this year, I had some abdominal pain, so I went to my doctor. He said he couldn't treat me and sent me to the ER. After 4 hours of waiting and only a 10-minute ultrasound, they said I was just fine. The bill was $7,000 for only 10 minutes of work. I was resolved to find something with RoboBed.
By providing mobility and remote interaction, the bed can solve problems in hospitals, doctors' offices, elderly care facilities, and patients' homes.
Oh no, we have a patient with a burst appendix. We need to go to the operating room.
Sorry, we need to deal with this now. We're switching to the front camera and starting the scan.
We're scanning the rooms to create an internal map. Look at the top image. This shows how to process the image. We convert to grayscale and blur, detect edges, find contours, and then detect the circles.
We determine the room based on the color. We know the angles based on the screen coordinates and can calculate the distance based on the circle size. Notice when Maria moves the target, the distance and angle are automatically updated. We use QR codes to tell the robot where to go. I'll confirm the operating room decision. The bed uses the map to turn to the room, then corrects the angle based on the camera. We send commands to the Tetrix so it can drive. Self-driving automatically isolates patients and prevents transmission of diseases like COVID-19.
We send commands to the 6 servos that perform this operation. The arm will have a built-in camera and can change tools for every job. Think of what we can do with the arm when we combine it with haptic feedback to measure force and remote operation. A doctor can perform 100% of the physical without the patient going to the doctor and without exposing either the doctor or the patient. There are 1.1 million US doctors. The average doctor's visit is only 5.2 minutes. We can learn from every doctor's visit and also from collecting data 24/7. RoboMed is a platform for medical innovation.
We've thought of the applications we can create with this platform. Here are some examples. We can detect skin problems, listen to the heart and lungs, inspect an injury, perform an ENT scan, a vision exam, supervise physical therapy using pose estimation, or perform an ultrasound.
If my doctor had this attachment, I wouldn't have needed to go to the ER. We would have saved $7,000. The Clarice ultrasound shown here costs $6,900, so it would be paid for in only one visit. My doctor caught COVID-19. With telemedicine, he wouldn't have been exposed and would still be able to treat patients. This bed is really practical. Technology and AI is improving, and the need has never been higher. Medical costs are skyrocketing, and the need for isolating is great. Number of elderly people is also growing rapidly.
We hope you've enjoyed our presentation. We look forward to presenting to you through Zoom and answering your questions.